Start the recording. Hello, hello. Welcome back, our last week of class together. First, an update. Do y'all remember the deal that I made with respect to evaluations? Mm-hmm. So the deal is twofold. University course evaluations, if all but 2 of you do it, so there's 26 of you, if at least 24 of you do it, everybody gets a point extra credit. Would you like to see how you stand? Drum roll, please. 17. You're at 17 out of 26. You're beating the other class, though. So, if but that just means if there's some peer pressure to be had amongst y'all, you got to work on that. I cannot tell who's completed an evaluation, but what I can do is email the people who haven't. So I will likely do that tomorrow. University evaluations close, I think, on Saturday night. The other half of my deal was the Qualtrics survey, which I think about half of you have done as well. That closes at the end of finals week, and if each of you who does that gets a point extra credit. I do that because I want to have a high response rate, but I'm also very interested in your feedback, and I do make changes as a function of what folks say. As an example, it used to be the case that the formative assessments, like the one that we're going to look through today, were actual quizzes. Like I would do them like pop quiz at the beginning of class, closed notes, time limit, graded for actual points. Can you imagine how popular those were? No. They hated them. They hated them so very much. So I stopped doing it. So I thought, let's take the pressure off. We'll let you complete these on your own time, and we'll go over the answers together. And that seems to work better. As another example, I had a suggestion, I think, the last semester, maybe 2 semesters ago, that when I post the videos, could I label what the slides were covered that day or what pages were covered that day? And I thought, well, that's an easy thing to do, and that would be very useful. So I started doing that. So any little things that you want to suggest that would make your experience better, that I can change, that I can fix, other than, I hate statistics, or why do I have to take this class? Like, that's not my fault. Those comments have to go someplace else, but hopefully you're not feeling like you hate it anymore. You're feeling like maybe this is something that you can incorporate into your research, or maybe just hate a little less. So I do value your feedback. Thank you for those of you who've completed them, and I hope to get those numbers up. I'll give you another update on Thursday. Another schedule update that we have is with respect to finals week. Let me get your course page open here. So I am going to be holding office hours during the time that I'm normally teaching during finals week, but we're not having class. So I will be on Zoom. I'll probably be in my basement at home, but from 12:30 to 4:30 on Tuesday, Thursday, I will be available. So if any of you needs help getting caught up or help with the last assignment, I am available during that time. I heard from 2 of the TAs. Nikki is also going to be available during finals week, so she has office hours on Mondays and Fridays. Kuhn is not, and I haven't heard back from Lexi yet, but once I get all 3 of those, I will post to the website when people are going to be having office hours so that you can check in with them as well. And your last homework is available. Homework 6 is due at the end of finals week. And we have gone over the information that you need to do that, so you should be able to do it, but we will review that again today as well. So any questions on schedule, logistics, work to be done? I updated grades this morning, including your formative assessment scores, so all 6 should be in there. You should have a current point total as to where you stand. If you look at your scores and you see any problems, please let me know, and I will be happy to track down the solutions. Okay, so we're good for that? Good for that so far? All right, then let's do this. How about the answer key for your formative assessment? Would it make you happy if I posted this when I'm done typing today? Would that be helpful? Okay, so for those of you who do not have the correct answers and are trying to keep up with me, don't. I'll post it. Just sit, chew, and listen. Well, I see people eating on the Zoom, and my son just finished a Rice Krispie bar like the size of his head that his dad came and bought him at the snack bar. So, nutrition killing the parenting, as I'm prone to do. So let's go through this then. We had 4 problems to do, all based on this equation. And I told you that you could forget centering for right now. So just assume that 0 is already a meaningful value. You don't have to worry about that. That way we're just tracking what goes where with respect to creating predicted outcomes and predicted slopes. So I asked for each of these questions to write out an equation and then to write out one of the programming statements. So this is the common structure that each of these would use. It would be up to you to figure out what goes in each of the blank spots. So the first one here is a predicted outcome. So we're asking for what would the model say the outcome should be for a person with combinations of these variables as such. And pretty much everyone got this right, who had attempted it at least. So this went really well. Note that there's nothing going next to beta 0 because beta 0 is independent of the predictors. We always have that, and it always contributes to everyone's score if an intercept is included in the model. So what goes here then is the value of the predictor that corresponds to beta 1 as its slope. That's the value for f. So in the instructions, I said f is 2, so I'm going to put 2 here. Likewise, this is the value for the g predictor that corresponds to the beta 2 slope, and I'm going to put a 3 here. This one is what? Finger question. 4. Yeah, there's a pattern here, in case you hadn't noticed this. I was trying to make this a little bit easy. 5. Yeah, and so then what goes in the first spot here? Yeah, this is 2. Yep, I'm trying to make this a little bigger. And beta 5 is attached to f and g, which means this is 3. And then last but not least, this one is f and h, so that's 2. And what goes here? 4. Yeah. So if you wrote 6 here, that's fine. If you went ahead and did the multiplication, but I wrote it this way so that you could see how the ingredients look. So then in each of these statements, what would go in there is what you put in the parentheses. So I'm going to fill in R because that's the one that is the least transparent. What goes first? The intercept. A 1. Yeah, so you can think about this as being multiplied by a 1 so that it looks the same. And actually, if I had taught you the matrix representation of this, there would be a column of 1s to make sure that the intercept has something to multiply. Aren't you glad I didn't do that, by the way? I could have done the class as, well, the solution is just a simple linear model of x transpose x inverse x transpose y, clearly. Right? I love the books that are written that way. Like QED. By the way, QED has a very funny definition on the Urban Dictionary, if you look it up. Something to giggle at after class. But given my little ears, I will refrain from saying what it says, but it's funny. You should check it out. But anyway, 1 goes here. So what goes in the second spot then in my R code? Yeah, the 2. So the multipliers, the terms in parentheses. So I put a 3 here, a 4 here, a 5 here, and a 6 here for the 2 times 3, and an 8 here. And I only know which is which in the context of how I wrote the model. The order is dictated by the order of the coefficients that you wrote. I'm going to actually make this all bold so it's a little bit easier to read. Does that help? Does that make it a little easier to see? Okay, good. Okay, any questions so far? So in the other packages, the numbers are right next to the things that they're multiplying, which makes the working memory load a little bit lower, but otherwise it's the same premise. Okay, G slope is the next one. So I will solve this one for us, and then I'll ask for you to help me with the next one. Step 1, if I'm going to predict what the model says the slope should be for any individual, is find all the model terms that have that slope in it. So don't need that. Let's see here. Let's see, I'll steal it from this right here. Do I need this? I do not, because it doesn't have a G in it. Do I need this? Yeah, I need one of those. So we'll write, I need a beta 2, and it's times G to start with. Don't need an H, don't need an I. Do I need this one?
Yeah.
Yeah, I need that one because it has a G in it. Beta 5 times F times G. And do I need this one? Nope, doesn't have a G in it. So folks who went wrong, this was the step where you went wrong. I had a whole lot of people say, well, it's a G slope for somebody with an F of 2, so I need to put something with the F in here. But F is the moderator. What I want is the G slope. So the main effect of F is irrelevant.
Mm-hmm.
So step 1, find all the terms that have the variable that you want the slope for. Step 2, what do I do next?
Put numbers.
Before I put the numbers in, factor it. Factor the variable out that it's the slope for. So I got beta 2 plus beta 5 times F. That is my G slope, that linear combination. So now I know what to write down here based on only needing these two terms to be involved. So if I go down to my R code, I put a 0 where the intercept is because I don't need that. The first fixed effect is for F, don't need one of those.
Mm.
The next one is for G, so what do I put here? A 1, yep.
Mm.
Yep, because it's like what I'm saying is that. What's next is the main effect of H, don't need that, don't need I. Now what goes in this spot? Yeah, it's this term right here, and I said 4, oops, come back, 4 in F of 2. So the 2 is what goes in parentheses. That's what goes here. And then I don't have the last interaction term, so that's 0.
Mm-hmm.
So of the folks who did not get this right, all of you made the same mistake of trying to put in the main effect of F also, because I think you were reading for F of 2, but it's the G slope is the unit of analysis. Okay. Questions on number 2? One second. Hey, Hugh. Yeah. Betty. I'm allowed to be the mask police with my own kid. So he's finished his giant Rice Krispie treat and is watching, probably, is it Zach Scott today, Betty? Who are you watching? No? Who is it? Zach's Mini?
Red Falcon.
Red Falcon? Oh, a different person. We're on to a different YouTube star. It did make me wonder, though. All of these YouTube people have merch that they sell. Like the one that he watches play Nintendo for a living, Zach Scott has like 5 million followers, and he has T-shirts that say, "Are you joking, freaking kidding me?" Because that's like one of his catchphrases. And so I was telling Jonathan about this after seeing it on there, and then Huey pipes up, and he'd really appreciate it if you'd order one. I thought, well, I'm not buying my 7-year-old an "Are you joking, freaking kidding me" T-shirt, but then it made me question, like, what would my T-shirt be?
Garbage day.
Happy Garbage Day might be one. You know, making stuff up since 2003, you know, something along those lines. I don't know what it would be, but it was thumb sideways. How you doing? Oh, that's a good one. How we doing? Yeah. Yeah, how we doing? With the hands. That, believe me or not, is not mine. I lifted that from the person who taught me stats as an undergrad, and I went through the first-year grad sequence as an undergrad. He would always do that. How we doing? So, yeah, with the 2 hands. It'd have to be like an emoji with 2 hands or something. So, I'll work on that for later. I will not be selling any merch anytime soon. The only thing I do to maintain my YouTube channel is 5 mouse clicks at the end of every class to load the video, and that's it. There's no fancy editing, there's no, you know, I'm not selling this stuff. Anywho, that's cool. All right, we good with that one? Okay, next one. Same principle, slightly more difficult. F slope. So I need all the terms that have F in them. So I need beta 1.
Mm-hmm.
I need both of these.
Mm-hmm.
So 5 and 6 are the other two. So we're going to write out beta 1 times F plus beta 5, which is F and G, I think. Is that right? And beta 6, which is F and H.
Yeah.
Is that right?
Yeah.
Okay. There we go. So those are my ingredients. Next step, factor.
Mm-hmm.
Or for those of you who remember calculus, I think I'm taking the first derivative of the function with respect to f. Can I get a confirm or deny on that? Is that we're secretly doing calculus? I just sort of snuck it in there a little bit. And here are my ingredients. So I do not need an intercept. Do I need, let's see, beta 1? Yes, I do. What goes here? A 1. Yep. Because I am, what's multiplying this thing right here is a 1. 1 second. There we go. And then, let's see, do I need the main effect of G? Nope. Main effect of H? Nope. Main effect of I? Nope. What goes here? The instructions said G of 3, so 3 goes there. H of 4, 4 goes there. How we doing? 2 thumbs up. Oh, that's got to be a new record.
Can I ask why you gave in the question for someone with G equals 3 and H equals 4? Was that just, did we ever use that?
These are values of the moderators that I want the F slope for. So the numbers are arbitrary. They would be guided by the context of the range for those 2 variables as to what reasonable things to ask for would be. So for instance, in your homework, you have interactions in the model between opponent type when playing Scrabble, easy versus hard, and there's only 2 possibilities. You can either play the easy opponent, which would be 0, or the difficult opponent, which would be 1. But the logic and the mechanism by which you can find the F slope for anybody is really what I'm after here. So just filling in the 3s or 4s is arbitrary. Okay. Ready for the last one? This was a tricky one. What goes here? Predicted I slope for someone with an F of 2, a G of 3, and an H of 4.
You mean to ignore?
Yeah, what's my process? Step 1. Find all the things that have I in them. The end. Beta 4. Beta, can't spell. There we go. Beta 4 times I. Factor out the I. Beta 4. The end. And yes, this was tricky. This was on purpose, though, because I'm trying to make a point. This is the I slope for these people. This is the I slope for anybody. Because according to this model, as it is specified, the I slope is entirely governed by beta 4. That makes it marginal, cough, cough, homework question, unconditional for everyone, regardless. So it is the I slope uniquely controlling for all the other predictors, but it's for everybody. It's not conditional on 0 or anything else. So then down here, 0, 0, 0, let's see, Nope, this one's still 0, I think. This is the one, right? Yeah, because the first one's the intercept. That's why I always write the 1, so I don't forget. So would I actually need to write this? Like in life, would I need to go to the trouble to write an extra statement to get this? No, beta 4 is going to show up in my output because I asked for it. So anytime that you look at one of these and your answer is not a linear combination, but there's only a 1 in one place, that's in your model already. That's it. That's already given directly as a fixed effect. It's only the others that have multiple values in multiple places that are linear combinations being added together. So the rest of these would be linear combinations. Okay. Questions on that? Yes?
When you say the word factor, what does that exactly mean?
Factor it out to me means like vacuum it out of every place.
So like exclude that number or area?
Yeah, because then what you can end up, basically what happens is that then that whole thing is one term that would multiply the variable. So I'm just rearranging the equation so that it looks easier to identify that this is the slope of this variable. Is there a synonym for factor that I can use? Other than vacuum it out, which I'm pretty sure is not a legit math term. Yeah.
I just wondering the terms.
I think factor it out is a legit term. Like that, there's something like back and whirling in my brain from like 10th grade that says that that's in there somewhere, but I could be wrong. Any math educators here? Science ed? People who know this know? Okay. I know there are. You just don't want to talk to me. Common multiplier? Okay, I'll take that. All right. So are we good with this? How about we do a little vocabulary? So all of these terms in here are unique effects. They can't be bivariate because there's more than one of them. Which are marginal and which are conditional? So F. Is this the F effect for everybody or the F effect only for certain people? The answer to that is F anywhere else in the equation? Yes, it is. It's in 2 places. So this is specifically the F effect when these terms drop out, which would only happen when G is 0 and H is 0. So F is unique conditional, what's known as a simple effect, which is a terrible phrase because simple effects are actually really complicated. How about G? Marginal or conditional? This can be a finger question. You can do like a C for conditional and like an M maybe. Yeah, this is conditional for the same reason. H, conditional for the same reason. I, this one is marginal, unconditional. This is the I slope for everybody. And then the interaction terms. Marginal or conditional?
Conditional, I think.
This is a
No.
tricky one.
Right, because they're interacting uniquely, so marginal.
They're interacting uniquely, so marginal. Yeah. Another way to say it is beta 5 is how the G slope changes as a function of F. Beta 5 is also how the F slope changes as a function of G. But how those slopes change as a function of the other variable is the same for everybody, because there is no other term in this model that has both F and G simultaneously. So it's the highest order term in the hierarchy, and that makes it unconditional marginal. Same with F and H. What if I did something like this? Beta 7. Oh, no, am I in equation? Thought I was. There we go. Beta 7 and I did something like F, G, H. In order to do that, I would also have to add the interaction of G and H. So let's do that. Beta 7, G, H plus, we'll make that one beta 8. There we go. Could I do that? The faces are like, oh, please don't. Please don't. I could, though. And in this case, now this is conditional. The F and G interaction is only the interaction when this thing drops out because H is 0. Because there's two different terms that have it as a component. Likewise, F and H is specifically when G is 0, G and H is specifically when F is 0, and the highest order term, which would be a three-way interaction, is unconditional marginal. So this is a big alphabet soup. The reason that I want you to know this as a concept, here's how I see people screw this up in practice, in journal articles, in dissertations, etc. It's very tempting to look at these slopes for the variables by themselves in these models and make conclusions about whether those predictors matter. Like if beta 1 is significant, then F matters, and if beta 2 is not significant, then G doesn't matter, but that's wrong. Because these are only for specific types of people given the moderation. So it's an incomplete story to only look at these ones and try to figure out how this variable affects your outcome, because this is only one simple slope out of a number of infinite possibilities. So that's why it matters. I want you to know which of these things you need to say is specific to the moderator variable equals 0 versus things that are not. Does that make sense as a concept, even if the math is a little bit crazy at the moment? Yeah. And we have more examples of interaction terms to do today to try and cement this for the case of quantitative variables interacting with each other. All right, so I'm going to take, let's see, which ones did I add? These two out so that we don't get messed up, because all the other answers would change without those. Okay, any more questions on this before I shut it down? Okay, then bye-bye. Let's go back to example 5. And would it be helpful to go back over the model we did last time, but as the one that's on your homework? Would that be helpful? Maybe? At least a little bit. Yes, and the scaffolding, use this one for homework 6. So I will tell you the story, by the way, of where homework 6 came from next time, given little ears in the classroom. But for now, I will say that section 1 is a main effects model where all of the predictors are entered individually without interaction terms, and section 2 involves adding 2 interaction terms of a binary predictor with a quantitative predictor, such as what we have right here. So the structure of this is very much the same as what I'm asking you to do, not a coincidence. So in order to test whether or not these two terms work together to improve the model R-square, that's a custom f-test that I have to ask for. So to assess whether or not, relative to the model where I just have main effects, whether these two new interaction terms significantly improve the R-square, significantly increase the amount of explained variance, that is contrast in SAS, that is test in Stata, where you would put the two new interaction terms only in those statements. And in R, it's a GLHT with this structure right here, where you're taking the slope and setting it equal to 0. So you're asking, like, what would happen if these two terms weren't here? And it gives you an f-test for the change in the R-square. So I've had a number of questions on that relative to homework 5. That was the new idea in homework 5, reappearing in homework 6 as well. There are also questions in homework about what the slope would be for the quantitative moderator variable for each level of the binary one. So for instance, given this model, what's being interacted is binary gender by age and binary gender by grip. So to get what the age slope would be, for instance, I start with the model. So you don't have to write out the equation, by the way. You can look at what's in your code. And all the terms that have the word age in them are relevant, and all the terms that do not are not. So we would come down here. Those are the ingredients. Factor out age. And here's how I would get the age slope for either gender. So I need the age slope at a minimum, and then I need the moderator value that I want the age slope for. So if it's for the group coded 0, I put a 0 here. If it's for the group coded 1, I get the 1. Same thing in stata, a little bit more explicit with the 0s and 1s being added together in a linear combination. And the same thing in R, albeit with this horrible system of 0s and 1s all written in a row. So the 1s are in the place where the age slope is. The second to last interaction term is age by gender, and so it's a 0 here because it's for the men, it's a 1 here because it's for the women. And the same is true for grip. The grip strength slope main effect is turned on, and then the last one customizes it for men versus women. All right. So then we went through the results last time. Would that be good to revisit in terms of what the parameters are? Yes? Okay, we went through the SAS results last time, so we can go through in a different package, I think. Here's R. Let's do R, since so many of you are being brave and learning R. I'm on page 13. That's where I'm at. So the intercept, always predicted outcome when all the predictors are 0. So for this context, it's the predicted cognition score for someone who is 85 with 9 pounds of grip, who is a man. So I write these as like men versus women. I put the one that's the reference first. And the N group for dementia, which means none. And I don't have to add anything to my sentence for these interaction terms because they're involving predictors that are already been mentioned. And now probably you can see the logic why I stick the centering constant onto the variable name, so that when I'm looking at it, I know who 0 is, without having to remember what I did in my code 3 pages ago. Okay, so the change in the R square relative to the main effects model, I have put here in a text box, and the significance test for that change is given by the GLHT results right here. So I have a note that this is, I want a degree of freedom 2 F-test for the 2 new interactions. It's setting those 2 interactions to 0 and saying what would happen. So then here is the F-test for that. So significant, thumbs up, non-significant, thumbs down. Here's an easy one. What happens? Yeah, this is a thumbs down. My p-value is 0.44, meaning that if we were talking about a population in which those interaction terms were truly 0, we would get interaction terms this large like 44% of the time. So not different than expected sampling error. So unsurprisingly then, the increase in R square that they provided is not significant. So 0.0022 increase in explained variance is not different than 0. That's what they're telling us. So age then, marginal or conditional? Conditional because of this. Grip, conditional, marginal. Conditional because of this. Sex, conditional or marginal? Doubly conditional. How about dementia group? Marginal. These are the dementia group differences for everybody. age, this is the age slope specifically in the 0 group. The 0 group is men, so this is the age slope in men. In men, for every year older you are, cognition goes down, so the negative there by 0.23, but that's non-significant. So I'd call that non-significantly negative. What happens to that age slope in women? Let me make this a little bit bigger. There we go. Which pattern is this? In women, the age slope is more positive, less positive, more negative, or less negative? Negative, negative. It's got to be a more negative. So it's negative 0.23 in men. It is more negative as sex goes to 1 by 0.29. So this is a slope difference. So in your homework, if there's anything that says the difference in the slopes, that's an interaction term. It's in your output. Interaction terms tell you slope differences as a function of the moderator variable. This is the gender difference in the age slope. In women, it is non-significantly more negative. So if I wanted to figure out what it would be in women, I have to add those two numbers together. And then the next question is, get the standard error for it. And you're like, you cannot add the standard errors together. It does not work. Generally speaking, I have hid that from you because I don't feel like it's useful to memorize. But anytime that you're doing linear combinations like this, the standard errors that go into that are not only their standard errors, but also their covariance across fixed effects. So the formula to compute a standard error by hand is much more complicated. So I don't see the utility in making you do that because the software will know which one it is and do it better and faster. So I don't know if the age slope in women is significant. So that's an instance in which I'd need to ask for that as a linear combination, which I already did. So here's my GLHT results for my two age slopes. The one for men was already given by the model, but I repeated it just for pedagogical purposes mostly. Here's the new one for women, and that is significant. So in that subgroup, age matters. It does not matter for men. However, the fact that the interaction is non-significant means that technically those slopes are not different from each other. Not significantly so, just numerically. Okay, how are we doing with that? That is my t-shirt. How are we doing? Someday. Let's see, let's do the other one. Here's the grip strength slope. For what kind of person? Conditional on what? Dudes. When gender equals 0, coded for men. What happens to it in men? This is the grip strength slope in men. What happens to it in women? More positive, less positive, more negative, or less negative? Less positive, yeah. So it's the slope that the interaction term is changing. It is making the grip strength slope less positive. Weaker, in other words. The effective grip strength is weaker in women, non-significantly, but numerically weaker. To get to what it is in women, I would take 0.69 minus 0.17, and here's the results for that given by my GLHT. So it looks like it is significant in both groups. The fact that the interaction term for their difference is not significant means that those are basically the same. So the grip strength slope in men of 0.69 and the grip strength slope in women of 0.52 are statistically equivalent, according to these results. And here are some words that say that, as always. Okay, questions? And here is an example of how to get predicted values out of the model, which is what you're doing in section 3. In R, you can do that using a prediction function. Go back to all the code here. So this type of idea right here. In the code online, I noticed when I ran R for your homework, it wasn't giving me enough significant digits. So I wrapped the summary for prediction in a print statement that added the number of digits to be printed. So on the online version of this, you can borrow that code and make sure that you get enough digits for the homework system. So this prediction function then, you would tell it which predictors to hold constant and constant at what values, the range of the predictors that you want it for. So it's low to high in increments of is the way that that works. That looks remarkably similar to what you would do in Stata with the margins command, which is the genesis for the R version of this. And in SAS, it is a longer way to do it by writing an estimate statement for each unique combination. But these are the same type of estimate statements that you did in your first question of your formative assessment, asking for predicted values. So the intercept goes here. We hold constant any variables that we don't want included, and such as dementia in this case, and we're varying gender, age, and grip. Okay. So questions on any of that code, model, output, interpretation, any of that? And your question can be, can you say that again? About any of it. If not, are you ready to see the next model? Why not? So this was a demonstration then. This follows the results that are reported in chapter 2 on your reading list of my book that describes these analyses. How to do this process given a quantitative by quantitative predictor interaction. So previously it was binary by quantitative. This is another variant. You can fit interaction terms to examine moderation in any kind of predictor. You do not have to have it be a certain kind. So given that sex did not interact significantly with age or grip strength, I took those out. In its place, I added this new term. So conceptually, the research question that goes along with adding this new term is, to what extent is the effective age stronger or weaker in people who are stronger or weaker? Does age matter more in strong people than weak people? That's one way I could phrase it. The other way, does grip strength matter more in people who are older versus younger? Where younger means 80 and older means 90. These are older adults in the story here. So then to ask whether this new term is going to significantly improve my R squared, do I need to do anything special? Do I need to ask for any special F-tests or extra code or any of that to ask if this one new term is going to improve my model R squared? I don't. Because if it's significant, that means the change in the R squared that it created is significant. One slope. If it's significant, the change in the R squared it created is significant too. One-to-one correspondence. So to explore the interaction, I'm going to ask for age slopes at prototypical levels of grip strength and grip strength slopes at prototypical levels of age. Now, what those levels should be is entirely dependent on the distribution of these predictors. What people commonly do is go +1 standard deviation in the predictor to have like a high group, the mean, and then -1 standard deviation to have like a low group. So I did that roughly, but I used whole numbers to make the math a little bit easier to track. So for instance, if I want to know the age slope, I borrow all the terms from the model that have age in them, I factor out age, and here's my ingredients. So the age slope for somebody who is relatively weak would be, for instance, 6 pounds of grip strength as -1 standard deviation on that particular variable. So if I want it for somebody who has 6 pounds and grip is centered at 9, I put a -3 for the interaction term. So I put a 1 here because nothing multiplies beta 1. At a minimum, that's what I need to make an age slope. What goes in the interaction term is the value of the moderator, the other variable. So -3 to get a moderator value of 6, 0 to get a moderator value of 9, which is where it's centered, and +3 to get a moderator value of 12 relative to 9. Likewise, grip strength slope. Same pattern, flip the direction of what the interaction term means. So now if I want the grip strength slope, that gets the 1, and the value that goes after the interaction term is for the value of age that I want the grip strength slope for. So -5 would give me 80, 0 would give me 85, and 5 would give me 90. And here are my fake people, or my predicted values for my prototypical people. The same thing would happen in stata. There's also a stata command that I wanted to show you using margins to get simple slopes. So stata folks, you're going to like this. Less typing for you. This command right here, dy dx, that allows you to get simple slopes of age as the variable after the dy dx for the ranges of the moderators given here. So in stata, this one line right here gives you the 3 lines that go below it. Dx, or dy dx first derivative with respect to age is what that means. So I can do the same thing to get a grip strength slope instead by putting grip here and putting the range of ages that I want it for over here, and that creates these 3 lines. And then predicted values from margins as well. Last but not least, R folks. We have, let's see, nothing new. This piece, there's your interaction term. Here are the age and grip slopes. And yes, there are ways to do the simple slopes with less typing, but those involve additional packages. I have that at the end of the code online, but I'm not going into it here for right now. And then prediction to get the predicted values. And then here's my pictures. Okay. Questions on any of this code? We have a lot of it here. But this is the new term. All right, let's roll through the answers then. So the new interaction term, relative to the model that has only main effects, improved the R-square by 0.01. So I've explained an additional 1% of the variance by adding in this interaction term. That doesn't sound like a lot, but it could be significant. Lo and behold, here's my age by grip interaction, which is significant. So the interaction term is significant, means I have significant moderation. That's the one thing that caused the change in the R-square, so I know that that change is significant too. All right, let's roll through the results. Reference person is the same because I haven't added any new predictors. Age and grip, marginal or conditional? Conditional, because they're both part of this interaction term right here. How about sex and dementia group? In this model, marginal or conditional? Marginal in this model. They don't interact with anything. So this is now the gender difference for everybody. These are the dementia group differences for everybody. Okay, zooming in so we can see the signs a little easier. So who is that the age slope for? It was men in the previous model, but those interaction terms have been replaced by a new one, this one right here. So what did you say? You did? No? Okay. Who is this the age slope for? The question is asking, at what point does this last term drop out? When would this reduce to 0?
At a lower age.
At what?
At a lower age?
The other variable is what it's conditional on. It's conditional on grip strength. Yeah, grip 9. So if somebody has 9 pounds of grip strength, their value on this predictor is 0, which would knock this whole thing out of their prediction, which would leave only this line as their slope for age. So this is the effective age specifically when the interacting variable is 0. So this is for somebody with 9 pounds of grip strength specifically. So these are age differences in people of medium strength levels, is how you can think about that. And in those kinds of people, age is significantly negative as a slope. So as age goes up, cognition goes down. What does the interaction term do to it? So as grip strength increases, or in people with higher grip strength, I should say, the age slope becomes, which of the 4 is this kind?
Less negative.
This is a less negative, yep. So does that mean that the effect is getting stronger or is it getting weaker? Weaker. If the answer is less anything, it's weaker. If the answer is more anything, it's stronger. So the way that I would interpret this coefficient then is a little bit trickier, but it's the exact same logic as if you had a binary variable. The interaction coefficient of 0.12 is how the age slope changes per unit grip. So if I have 10 pounds of grip strength instead of 9, my slope for age is minus 0.33 plus 0.12. If I have 11 pounds, it's another plus 1.2. So this is how the slope changes per unit moderator. And this is where the simple slopes, is that funny, buddy? Yeah, he's laughing. I'm pretty sure it's not at me, but I could be wrong. Look at mommy tank on garbage day. This is where the simple slope requests come in handy. So here's the things that we asked for. By the way, this is sometimes called probing an interaction term, but I really don't like that word. It reminds me of the South Park episode, the very first one, where Cartman was convinced that aliens were doing experiments on him that involved probes. So that's what it makes me think of, and I just don't like that word. But that is what it is sometimes called. So here's the age slope that we got out of our model, the minus 33. In people who are stronger, like for instance at 12 pounds, here's what it becomes. Here's the p-value for it, which is non-significant. In people who are weaker, the age slope is more negative instead, and it's significant. So putting that all together, if I were to talk about this as a normal human and not your stats instructor, right? Because your results sections have to have normal human language in them, not just F, P, blah, blah, T, word salad, soup salad. I would say that age matters less the stronger you are. That's how I would say that. That's what less negative means to me. Age matters less in stronger people. Or you could say that grip strength is a protective factor against the deleterious effects of aging. How's that for a GRE word? Yeah, it's more negative, right? But how fancy you want to get with more negative is up to you, or less negative, excuse me. Age matters less as grip strength increases. That's what that means. Matters is my way of saying the effect of the slope. The effect of age on cognition is weakened in stronger people. So it's significant age slope at grip strength equals 6. It's a significant age slope at grip strength equals 9, but by the time we get to 12, it's non-significant. So this tells us that somewhere between 9 pounds and 12 pounds, the age slope essentially becomes 0. It shuts off at some point in there. And if we kept going higher and higher, it would eventually turn into a positive slope that's significant. Because it'll just keep getting less negative and into positive, heading that same way on the number line. Okay, do you want to do grip strength? So here's what's going to happen. Here's the simple slopes. Here's what's given by the model, age 85. It looks like the grip strength slope is close to 0, but positive in younger people. It's significantly positive in middle people, near the mean, and it's significantly more positive, it looks like, in older people. So this pattern right here tells me that this is going to be a more positive. And sure enough, the way I would talk about that is the effective grip strength is stronger by 0.12 for every year of age. So grip strength matters more in older people. If we look at the p-values associated with these specific predictions, there is no effective grip strength at age 80. There is a significantly positive effect at 85. So somewhere between 80 and 85 is when grip strength starts having a significant positive slope. After that, it stays positive. So Chelsea, to your question earlier, why did I pick values 3 and 4? It's completely arbitrary. So you will see folks do this. They'll pick, low values, middle values, and high values, and they'll report the slopes. And they'll make pictures like this. So for instance, this picture on the left is how I would depict an interaction term where the point of the story is all about how grip strength matters and age is the moderator. So grip strength, I said that backwards. Age is what matters and grip is the moderator. So, because age is on the x-axis here. So the slope of the red line is specific to somebody with grip equals 9. That's what's given by the model. And this is a negative slope right here. It becomes more negative as grip decreases and less negative as grip increases. So the green line is not significant as a slope. The red line is, and the blue line is. I can go the other way by changing what the x-axis is. Now the story is about how grip predicts cognition differently as a function of age. The green line was significant, the red line was significant, the blue line was not significant. So if I follow this trend, eventually the pattern is such that we'll have a negative slope if I keep going in younger people. Likewise, if I come over here, If I keep going this way and I go to stronger and stronger people, eventually this will turn into a positive slope. So rather than picking a point, like these arbitrary points on this continuous variable to look at, wouldn't it be helpful to know, like, at what point it shuts off and it turns on? Because I know from this one's significant and this one's not. It's somewhere between 9 and 12. Likewise, for grip strength, it's somewhere between age and 80 and 85. So the part that I'll show you just very briefly, this idea of at what point do the slopes turn on and turn off as a function of the moderator is what's known as regions of significance. This is a technique that's been around since, I think, literally the 1930s, and until recently people figured out a way to hack it for this purpose. So I wrote a SAS program that will compute this for you. I also have an Excel spreadsheet that has these formulas plugged into it, and there are R packages as well that allow you to compute these things called regions of significance. So very quickly here, the logic, so this is slide 21, is taking the t-test result for where significance would start and rearranging the formula so that we can solve for where that is. In order to compute this, we have to get something, an additional piece of output that you're not used to seeing, which is called the asymptotic covariance matrix of the fixed effects. Because there's this piece in the formula to compute this that involves the covariance among the fixed effects. So in the example, I have figured out how, I'll show you what this looks like. So here is all of the same output from Stata, the individual simple slopes for all of that, and the pictures that Stata drew me from Margin's plot. And here is the R version of it. Here are the simple slopes that I requested. And here's regions of significance as one bonus piece here that we'll look at very quickly. In order to get all of the things that are needed for the equations to compute these things, we need one additional piece of output in SAS that is from a different procedure called mixed. Mixed is used for multi-level and mixed effects models. It has this COV-B thing that we need. In Stata, it's a separate statement after a regress command called stat-vce, which prints this out. And in R, it shows up as an object that is saved from the linear model here. vcov is what it's called. And this is the additional piece of output that we need. So this is something that you folks haven't seen yet. In this matrix, what's on the diagonal are the standard errors squared of each of the terms. So their sampling variance is what these things are called. The off-diagonal elements are the covariances among the standard errors. And I know that sounds kind of crazy, but think about it this way. It's like if you're not sure what the age slope is going to be and you're off a little bit, then that's going to affect what the other slopes should be because everything has to work together. So what we need to fill in to do the formula to compute regions of significance are the covariances among the common terms. So here is the results of a program that I wrote to compute this. First, for the grip strength slope as the target, it computes the regions at which it changes from negative to neutral to positive. So in this case, the grip strength slope was significantly positive at age 85. It will be significantly negative below age 70. It will be non-significant between the two, and it will be significantly positive for anyone who is above 82 years of age. So this gives the ranges of the moderator value for quantitative predictors at which the slope is expected to be negative, neutral, or positive. And then the question is, relative to the distribution of age in the data set, how many people would this affect? So like this lower bound here of 70, this is useless information to me because no one in my study is 70. But it's a model prediction. About half the people in the study are above age 82. So for about half the sample, there's a significant effect of grip strength in a positive direction, and about half the sample, it's non-significant. I can do the same thing heading the other way for the age slope. So the age slope was significant somewhere between, I think, 6 and 12. So the lower bound here is 9.6 and the upper bound is 18. So that means that it's going to be a significantly negative age slope below this point, non-significant in the middle, and then significantly positive after that point. And we have very few people who would be anywhere near 18 pounds of grip strength. And there is R code. Did I put it in here? Yes, I did. R has a package that I borrowed. I forget which one it is, but it's in your online code that computes these things for you. So you can do regions of significance there. So I know that was a very quick overview. This is more like, if you need to do this in the future, here are some resources. That's all I'm going for here. If you have quantitative by quantitative interactions, rather than picking arbitrary points to look at simple slopes at, you can figure out where they turn on and where they turn off. I find that more useful. And so this is discussed at greater length in chapter 2 in the book. And here's some words, as well as what I would say would be a full report of what happened with respect to the parameter estimates, their effect sizes, all the F-tests for everything, and all the interpretations. So here's additional output that I generated for this that gives partial Ds and partial Rs for each of these. So added the Ts, of course. And that's it. That's it. Just a little, just a little complexity. It could be worse. So what I didn't have time for this year, which I was hoping to, but then I never have time for everything I hoped to at the beginning, is this type of process for when you have predictors that take more than one slope. So like if you had dementia group as a 3-category variable and you wanted to interact that with H, then you would have to have 2 interaction slopes in the same way that you have to have 2 dummy code slopes for dementia group in the first place. And that's what this last unit 7 was going to be about. So I have materials from a previous course where I built the materials but didn't have time to give them. So I did videos from just off on the side, and those links are posted here for that. What we're going to do with our last class, though, is a new lecture that is still being built, so I will let you know as soon as that is ready to be downloaded, that talks about sort of what are the assumptions that we need to believe in to do the models that you've learned in this class. And if those are not plausible, what do you do instead? Because believe it or not, this is not all there is to know. If there were, then I would not have a job. There's a lot more that's still out there beyond this. But the good news is that every single thing you learned in this class, you would build on to do more complex analyses. So we'll talk about that next time. All right. Questions or comments? 3:10. It's time to be quiet, Lisa. Now we're good for now? Okay, well then, office hours start at 3:30. Let me know if you need anything. Homework is due in a week and a half. Otherwise, I'll see you Thursday. Thanks for being here. Bye.
Thank you.